So in this video, we're going to look at solving an absolute value inequality in a couple of special cases. So these are instances that don't typically show up when we're working through real life application problems, but we want to talk about them anyways, just in case they arise in the homework or something. So this one says the absolute value of 3 minus 2x has to be greater than or equal to negative 2. And this is one where we would need to be careful. We see the greater than symbol, and based on what we did in the previous videos, you might want to say, hey, it's a greater than situation, so I'm going to break it into two or statements, and I'm going to get 3 minus 2x is less than... but the cases we looked at, k had to be a positive real number. This thing here had to be a positive real number. Now it's a negative number. So we have to take pause for a moment. We can't just kind of blindly go with it's greater than, so I'm going to get an or situation where I have a union of two things. So we want to think about this carefully. Remember that the absolute value represents distance from 0. And remember that distance cannot be negative. So distance is either going to be a positive real number, or the distance from 0 could be 0. So if we asked how far 0 was from itself, it would be a distance of 0 units away. Either way, it is always the case that the absolute value of 3 minus 2x, because the absolute value is measuring distance, this number that pops out of here for whatever choice of x we make is always going to be greater than or equal to 0. For all real numbers x, it doesn't matter what you put in here, this thing can't give you a negative output. So because this output can never be negative, the output will always be bigger than negative 2 no matter what we choose for x. So the idea is we'd say something like this. We'd say for all real numbers x, we know that the absolute value 3 minus 2x is always going to be greater than or equal to 0. Therefore, the absolute value of 3 minus 2x will always be greater than negative 2. And it won't matter what we choose for x. This means x can be any real number you want. So instead of getting two intervals as solutions joined with the word or the union symbol, we just discover that x can be any real number going from negative infinity to infinity. It doesn't matter what you choose for x. The absolute value is going to be a non-negative number, therefore it will be bigger than negative 2. So the other kind of special case, we could ask this question instead. We could say, well, what if the absolute value is less than negative 2? Well, if the absolute value is less than negative 2, then the absolute value is a negative number. But what do we know? We know that 4x minus 3, because it's a distance from 0, and distance is always non-negative, we know that this thing here has to be greater than or equal to 0. So when will a number that's bigger, when will a number that's greater than or equal to 0 be smaller than negative 2? And the answer is never. There's no x you can choose that will make the absolute value generate a negative output. So there's no solution to this particular inequality. There's no solution. And in interval notation, for no solution, we would say x is an element of the empty set. Here's the list of everything that works. Nothing works. There's no solution.